Okay, so we're doing trig proofs. This is lesson N-2, and we're going to basically continue on with lesson 4-1, where we simplified trig expressions. You'll notice the difference here is we now have an equal sign. So we're going to follow these instructions. It says use the basic 8 identities. Okay, so if you've got your 4-1 notes, the ones they're referring to, we're going to use these over and over for this lesson. Okay, so if you need to, pause a moment and go pick those up. Also handy would be to write those at the top of your A42 worksheet. So as you're working, you just look up and see which one you want to use. Okay, so here we have tan x over sine x equals secant x. Now it says to make it equal the right side. So we're just not doing anything with this right side. We're only working with this tan x sine x. Okay, so I look at my identity list, and the only thing I see for tangent is sine theta cosine theta. Okay, so I'm going to replace tan x with sine x over cosine x. Okay, and then that's over sine x. And it still equals secant x. Okay, so this means to divide. So I'm going to rewrite that as sine x over cosine x divided by sine x. And that equals secant x. Okay. And I'm going to go ahead and move this out of my way for a minute, and we'll deal with that on the next thing. All right, so if I'm dividing, right, it means to multiply by the reciprocal. So the reciprocal of sine x is 1 over sine x. And I still have sine x times cosine x. And that equals secant x. Okay, so I'm because I'm multiplying, equivalent factors can divide out to 1. So I now have 1 over cosine x equals secant x. And if I check my identity list, 1 over cosine x is the same as secant. So we replace 1 over cosine with secant. And we have now shown that the left side is equal to the right side. Okay, so we're just using the basic 8 identities, simplifying the left side until it equals the right side. Okay, all right, let's try another one. Looking at this, and I see tangent x, cotangent x, and I remember from my identities list, sine over cosine versus cosine over sine. So I'm going to replace them, and this will be sine x over cosine x plus cosine x over sine x. Okay, in order to add fractions, they have to have common denominators. So I'm going to change my denominator to be sine x cosine x, right? So this one would need sine x. So we multiply the numerator and the denominator by sine x. And this would need cosine x, so we multiply the numerator and the denominator by cosine x. And we now have sine squared x over sine x cosine x plus cosine squared x over sine x cosine x equals 1 over sine x cosine x. Okay, so we now know to add the fractions, we add the numerators, so sine squared x plus cosine squared x all over sine x cosine x equals 1 over sine x cosine x. Okay, so sine squared x, cosine squared x, I check, and sure enough, that matches my identity, and it says that is equal to 1. So all of that is equal to 1. So I now have 1 over sine x cosine x is equal to 1 over sine x cosine x. So we're done. Okay, we have one more example. We have 1 plus tan squared x times cosine squared x equals 1. All right. Now we could go ahead and distribute the cosine squared x to both, but this looks vaguely familiar. Hopefully it does to you as well. Okay, if I check my list over here, 1 plus tangent squared x equals secant squared. So if I use that identity, I can replace that with secant squared x times cosine x squared x. All right, so now that I have secant squared x, I know that's 1 over cosine squared x, again from my identities, times cosine squared x. And when I'm because I'm multiplying, right, like factors in the numerator and denominator divide out to 1. So this is 1 equals 1. And that's pretty much it. So it's just yesterday with an equal sign. Okay, good luck.